Intel's CPUs in the AI era, still alive and kicking. GPUs are in the spotlight when it comes to AI, and for good reason. They're the workhorses behind the massive computational demands of training large language models, powering image recognition systems, and running real-time inference. At the same time, Intel's financial struggles and waning dominance in the semiconductor industry often make headlines, leading many to overlook or even forget the significant role that Intel's CPUs still play in AI data centers. But the truth is, despite all the attention on NVIDIA and AMD, Intel's processors remain a foundational component in the AI stack, especially behind the scenes. While GPUs do the heavy mathematical lifting, particularly for deep learning, CPUs are the orchestrators. They manage the system, handle data movement, and ensure everything runs smoothly. In this context, Intel's Xeon processors are still widely used. They take on a range of critical responsibilities, such as pre-processing massive datasets, managing memory and I/O operations, and coordinating the workflows between multiple GPUs. For example, when a model is trained on several NVIDIA H100s, it's often an Intel Xeon CPU in the background, managing how data gets to those GPUs and how the results get written back to storage. Intel has also been pushing optimizations specifically for AI workloads, with features like DL Boost based on AVX5112 extensions and tools like OpenVINO. Intel is still very much in the game when it comes to AI inference, especially in edge and low-latency environments, where deploying a full-blown GPU isn't always viable. Their CPUs are increasingly used for running smaller models or handling inference tasks that don't require the sheer parallelism of a GPU. Recent generations of Intel Xeon scalable processors, including Ice Lake and Sapphire Rapids, come with dedicated AI acceleration and support for high-speed interconnects like PCIe 4.0 and 5.0. Making them even more capable in data-heavy environments. A common question that comes up, especially among those following consumer tech trends, is why Apple's M1 through M4 chips, known for their impressive performance and efficiency, aren't used in AI data centers. After all, these chips boast integrated neural engines, high core counts, and industry-leading performance per watt. But the answer lies not in raw speed, but in architecture, ecosystem, and scalability. Apple's M-series chips are built specifically for their own devices, MacBooks, iPads, and iMacs. They're optimized for tight integration, energy efficiency, and performance within a sealed, single-machine environment. This makes them perfect for consumer-grade AI tasks like image classification, voice recognition, and local inference, but not suitable for large-scale distributed AI infrastructure. Additionally, AI data centers rely heavily on ecosystems built around Linux, containerization, such as Docker, Kubernetes, and GPU frameworks like CUDA. While macOS supports some developer tooling, and Linux has recently been ported to run on Apple Silicon, it's nowhere near as mature or stable as the software stacks built for x86, Intel AMD, or server-grade ARM platforms. And while Apple's Neural Engine is excellent for on-device inference, it's a fixed-function unit, not a general-purpose processor like a GPU. You can't train a large transformer model on it or use it for high-throughput server-side workloads. Of course, the landscape is evolving. AMD's EPYC chips are gaining traction due to their superior core counts and competitive pricing. In AI inference workloads and even some data pre-processing pipelines, AMD is carving out serious ground. And the momentum is shifting. Hyperscalers are increasingly choosing AMD for general-purpose compute, which surrounds the AI-heavy GPU racks. Is AMD winning everywhere? No. But in many cases, they're doing what Intel used to do to its own competitors, offering good enough plus better efficiency for less money. In addition, ARM-based CPUs are making waves in cloud-native workloads. Amazon's Graviton ARM-based chips are custom-designed for cloud-native workloads, including AI inference and orchestration. They're not GPU killers, but they're cheap, scalable, and efficient. Moreover, Google has TPUs, AWS has Inferentia and Trainium. Meta's working on its own silicon. This trend toward vertical integration and custom hardware could marginalize general-purpose CPUs entirely in certain AI pipelines. Basically, the game is shifting from who makes the best CPU to who controls the entire compute stack. In spite of these challenges, Intel still dominates a large portion of the legacy data center infrastructure, and its software ecosystem remains one of the most mature in the industry. Many AI frameworks, including TensorFlow and PyTorch, continue to offer finely tuned performance on Intel architecture. In addition, Intel developed Gaudi AI accelerators, aiming at NVIDIA's turf. So, while the headlines may suggest otherwise, Intel isn't out of the AI race. Not by a long shot. Their CPUs continue to be a critical piece of the puzzle, enabling AI systems to function efficiently and reliably behind the curtain, even as GPUs steal the show. And despite Apple's impressive strides in chip design for personal computing, the needs of the data center world remain fundamentally different, where Intel's server-class CPUs still play a central, irreplaceable role. Can Intel be dethroned in AI data centers? It could happen, but it won't be immediate. Intel's legacy footprint, software ecosystem, and current server presence buy them time, maybe years, to adapt or reposition. They're still alive and kicking, but the ring they're fighting in is changing fast. If they don't pivot hard, alive and limping could be the next chapter. Do you think Intel's dominant position in AI data centers will eventually be overtaken by AMD's EPYC processors or ARM-based alternatives? Can Intel pull off a reinvention, the way Andy Grove famously pivoted the company out of the DRAM business in the face of Japanese competition? Or are we watching the slow decline of another once great tech titan like DEC or SGI? I'd love to hear your thoughts. Drop a comment below. And if you found this video helpful, don't forget to like, share, and subscribe.